Hey guys, welcome back to another episode of Simulio. Sorry for starting so incredibly late today. First of all, I did wake up a little bit late. I didn't get up until 5:05. I'm not exactly sure why it took so long to get up. But then after getting up at 5:05, I got everything ready and tried to start the stream at 5:15. But for some reason, Twitch just did not want to load my stream. I don't know what the deal was, but it took some time. Anyway, point is, we're streaming now. We have everything kind of sort of working from yesterday, so I want to start by basically going over what we have done from yesterday. So let's go ahead and open up CD Projekt, Simuleos, and of course gift wrapping. Do the same thing over here, CD Projekt, Simuleos, and of course gift wrapping. And now what we're going to do is run the make command. Okay, now this is going to break if we run the Jarvis command. However, yeah, this is totally going to break. Yep, totally broke. Okay, good. So now let's go into jarvis.cpp. And let's get somewhere with this. So what I'm going to do, instead of doing what we're currently doing, which is outputting all of these lines right here, what I'm going to do, sorry for the young guys, is I'm going to, let's see, comment this guy out, and this guy out. Oop. Yeah, that's what I thought. And then what I'm going to do is, let me see, I'm going to animate a new line here. So let me go ahead and yank this guy, paste it down here, and I'm going to animate the line from 0A to B. Where's A and B? B.index. Oh, yeah, I guess what we should do is probably do a .c, and so let's go up here, let's go ahead and define .c. So it's going to be c.x and c.y, and it's going to be basically the same as up here. So let's go ahead and, what is A defined as? One second, we got to think here. A is defined there, B is defined here. Let's go ahead and define c, yank, to yank. Let's paste it down here. There and there. And this is going to be equal to par.points, and we're just going to do rx. RC, sorry about that. Like the circuit, whatever you want. So it's going to be par.points, j.x. Except in this case, it's not going to be par.points. It is going to be, one second. I suppose we should do all this C stuff after the for loop, I think. That's, I think, what we should do. Sorry, I'm lowering my sleeves because it is a little bit chilly in here. Just chilly enough that I need maybe potentially longer sleeves. Okay, so I think I just realized a fatal flaw in what I was just doing. So let me just go ahead for now. Let's go ahead and close all of these guys. And let's grab yank 3 yank. Paste it down here. Close this and then do RC. RC there. And what I want to do is, let me see, animate current line, A to B, but I want this to be AC. And then I think this will do it. So let's go over here. And actually, I want to call this, instead of line color, I want to call it wrap color. One second, let's change this to a wrap. Okay, go over here, and now let's run make one more time, just to make sure it runs. It says B is not used, line color is not used. Yeah, fair enough, that's because we're not fully done yet. Run Jarvis, make sure it does compile, which I think it should. Yep, I think it's working. So now what I want to do is run the last Mirage. Okay, just to show what we have so far. So far we can generate a random distribution of points, which looks pretty good. And then we're not doing exactly what I wanted to do. Crap. What did I do wrong? One second, let me think. A. Oh, you know what I should do? One second, let me just... C.point C, where's C defined as? C is par.points J. But what I actually want to do, let me think here. I don't want to animate this. Oh, I see. I did this incorrectly. Let me just go ahead and let me see, what do we have here? Angle temp. A is defined up there, so yank 3 yank. And let's actually just paste these down here. One second. Hey, Sam. The man, the myth, the simulator. How are you, man? I'm glad you're here. So what do we do here? So C, what I want it to be is not par.points. I want it to be next hole .x, and that should be okay. Let's do next hole, and then this one, instead of par.points, is going to be next hole. One second, hole. And that should do what I want it to do. So let me go ahead and do the last make. Seems to be okay. ./Jarvis. And the last Mirage. Once it's done. And let's see what happens. Here's all the points. And there we go. There's 1, 2. Why is this taking so long? 1 second. Oh, I know why it's taking so long. It's taking so long because what we're doing is just got done walking a little walk jog. Oh, cool. Cool. I'm glad you're here, man. So what are we going to do? I have something in here. That one. Let's go ahead and remove that one. So now we're going to do Mirage temp image.png. Nope, I want to do make. Okay, and what I'm going to do next is I'm going to say Jarvis, and then I'm going to run Mirage. Okay, so now we have this. So let's scroll down, and we should see, yep, okay. So they're all generated at the same time, but we do clearly map out the convex hull here. So what I'm going to do, guys, is I'm going to kind of mess with things a little bit. I'm going to have 3 layers. One for all the individual lines, which is going to be on the very background layer. Another for the gift wrap. And then finally, a last one for the points themselves. Sorry about the yawn, guys. And the reason I want to do it this way is because it makes a little bit more sense in terms of how I want to draw these guys. So, like, for example, if we zoom in here, you'll note that at each of these points, we have a little bit of a gap. And we could fix this in a number of different ways. But I don't know if I like the idea of having the line on the outside of these points. I kind of like them on the inside of the points anyway, just because aesthetically I think they're a little bit more pleasing. So the first thing I'm going to do is the following. I'm going to search through the entire space. Let me think. Yes, I'm going to search through the entire space. And I'm going to say search and replace layer of 1. And I'm going to have to do this. 1. With layer of 0. And that, I think, should do it. If I can do it right. Let's try it one more time. So it's going to be this S, and it will be layer of 1 with layer of 0, G. Oh, it's layers with an S. Oh my gosh. That's what I was doing wrong. So S, one more time, layers of 0. Oh, it's layers of 1, actually. If I can do this right. Layers of 0, G. There we go, got that done. Let's go over here. Let's, oh, I just realized I may have done this wrong. But that's okay. So let me go ahead and undo that one. 1 second. I may have just done something really, really stupid here. Screw it. Let me quit this. Open it up again. There we go. Got it. Okay, so now let me find all the layers of 1. Of 1. There we go. Oh my gosh, I did it again. Layers. What on earth? There we go. Layers of 1. There. Okay, layers of 1. I know you exist. Layers 2. Layers. Here are layers. Layers of 0. Oh, I must have accidentally saved the switch, I guess. Yeah, I totally did. Okay, so this is all going to be drawn on 1 layer then. And what I want to do is actually draw these points on layer 1. So let's go ahead and do 1 here. 1 there. Well, actually, those are okay staying at 0. 0, there we go. And then want to do par.points. Let me see, what do I have here? R0 or R1, sorry about that. R1. There. There. Layers let's say 0.current frame. There's 1.current frame. Should be okay. So now let's see what happens if we write this and make that. Give it a second. Now let's run Jarvis. Give it a second to do its thing. We're going to do the last Mirage. Okay, let's scroll down and let's see what happens. So now we should have, yep, all the points are being drawn on the back end here. Okay, however, what I want to do is, let me think here. I got to think real quick. Do I want all these additional lines that we're going to be drawing? Yeah, I got to figure out how to clear a context. For some reason, what we were doing before did not work, and I'm not exactly sure why. So let me see, why would it not have worked, that clearing of the context? That is a very good question. Clear context here. Okay. So what we want to do is clear the bottom layer. We want to clear the bottom layer. So we do clear context on the frame context of layers of 0.current frame. I think it was layers of 1.current frame last time. So I guess at some point, maybe... Yeah, I'm not sure. I have no idea. Okay, so here's what I'm going to do. I'm going to actually add a +1 to all of these layers, so that we actually have 3 layers, and the bottom layer is going to be all of those lines. And I realize this is kind of a sticky way to do it. In the future, we'll probably find a better way to do it, but let's go ahead and change this to an R3. Layers of 0. And now what we're going to do is anytime we see a layers of 1, it's actually going to be a layers of 2. So let's go in here, layers of 0 is still fine there, but all these guys need to be changed to a layer of 2. So let's do an R2, 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 R2. Then we're going to say is equal to R2, there we go. And we're also going to do yank paste, and we're going to say layers of 1. Okay, now the next thing we need to do is when we go down here, here's where things are going to get a little bit complicated. So we need to do, in here, layers of 0, and layers of 1 plus plus. Let me do a yank paste, layers of R1. And in here, instead of clear context, let me go ahead and change this. Let's just do animate line here, line color there. And let me change the line color just a little bit so that it is a little bit transparent. So let's change this to a I0.5. There we go. Okay, so now we should be drawing on the back context there. And then for this guy, instead of layers of 0, I'm going to do layers of 1. Just do A1 there. Is that all I need to do? Animate line. I mean, that's okay to stay 0 because they're all the same resolution. So let's just do a quick make, just to see what happens, and let's do a Jarvis. Okay, give this guy a second to do his thing, and now let's do Mirage. Scroll down. Yeah, okay. Let me just give this guy a number of more frames to work with. So let me do, instead of what I'm currently working on, let me do VI. What do I want to do here? I want to do... Wait, I have to think here. I want to do Mirage. I'm sorry, visualization. And then I want to do, let me see here. Visualization Cairo. And then Cairo viz.h. Okay, 1 second. Let's change this to 1200 frames. And now let's make it again. Oh, actually, we can just run... no, we gotta make it again. Give it a second, and now let's run Jarvis. Alright, now let's see what happens. We're gonna let it generate its 1200 frames, and hopefully, this will start to look a little bit different. 0, 1... Wait, why is it taking so much longer for each one of these guys this time? Interesting. Oh, no, I bet you this is how long it took initially for each of these guys. However... Okay, I know what's happening. This is okay. This is okay. At some point, we just run out of points to draw. Okay, give it a second. It's now rendering all the images, I think. And then once it's done, I'm just going to run Mirage. And we're going to see what happens. Okay, so this is what's happening here. We scroll down, we have all the points being generated. Then we go down, we generate 1 line, 2 line, 3 line, 4 line, 5 line, 6 line, 7 line, 8 line, 9 line. Now, does this at all resemble a present? Or should we have the lines disappear? I think we should have the lines disappear. Also, when we draw these points, we should draw these points on 3 instead of 1. Oh, on 2. No, they're already being drawn on 2. Okay, so where's this guy being drawn? Layers of 1. Wait a minute, what? Layers of 1? Layers of 1 at current frame. These guys are being drawn on layers of 1. Why are they being drawn over the points? 1 second, I gotta think here. Layers of 2. Grow circle, layers of 2. Yeah, these guys are totally being drawn on layers of 2. So why is layers of 1 appearing over layers of 2? Let me see. Well, that's a little weird. Let's also zoom in here on the circle. I have a feeling we're constantly drawing this line. I don't know why, I just have that feeling. Okay, so there's a couple things that I want to do here then. First of all, I have to figure out why we're drawing over the points when we should be drawing under the points. So let's go ahead and figure that one out. And second of all, we need to clear this context. So let's go through and do that too. So we're going to do VI. And I guess we're just going to go back to CarVisualization.cpp. And let's go to draw layer. Here we are here. We say fort size t I equals 0, I less than number of frames. We're going to say size key j equals layer.size. Let me see. Yeah, so we have a vector of frames. And we say Cairo set source, layer of 0, frame context, I. And we say layer of j, frame surface, I, 0, 0. We do Cairo paint layer of 0. Okay, so I see what we're doing. Layer of size minus 1. Why do we have to do layer.size minus 1? Oh, I see what we're doing. Okay, so we're going backwards. Okay, so that should work then. Okay, but it's not working. That's the problem. Cairo surface right to PNG. Yeah, that's okay. Oh, sorry for the yawn, guys. Okay. So, what is another way to think about this? Let me think. Another way to think about this. Why are we drawing above the points? Let me see. Am I doing this wrong? Layers of 0 dot current frame, layers of 1 dot current frame, layers of 2 dot current frame. So we're drawing growing circle on layers of 2. Layers of 2, layers of 2, layers. Let me look. Layers. Here we are. There. 2, 2, 2, 2. Yeah, okay, so it looks like we're totally growing the circles on layer 2. Okay, so let's pop down here. Layers of 0 dot current frame. Let me see. There. Animate line on layers of 0. That's good. Layers 0 dot frame context. Doesn't matter. Current frame. Let me see. Layer 0 resolution X. Let me see. Okay, that should be okay. Layers of 0 resolution X. Good. C.Y should be okay. Layers of 1. Yeah, I never use layers of 2 again. Dang, that's unfortunate. Why is it doing that? Pop over here. Quit. And let's do Mirage again. Scroll down a little bit. Okay, yeah, that's clearly over. Yeah, there's not even a question there. It's clearly writing over. So why? Why is it overwriting instead of underwriting? We had it underwriting just a second ago. Let me see. Layers of 1. Well, I have no idea, guys. Let me see. So what could the issue be here then? Layers of 0. Layers of 2. Is there any way to easily debug this? We could watch layers of 2. It doesn't really help that much. Product points dot size. That's the number of points we have. 1 second, guys. I'll be back in just a second. Okay, I'm back. Sorry about that. So again, I'm still a little bit sick, so I've been, I don't know what the issue is, but I'm definitely getting better, but just not as great as I could be. So, okay. I can't put both headphones in. I don't know what it is. When I put both headphones in, I just get paranoid. Okay, so what are we going to do? We're going to try to figure out why one layer is being drawn above the other layer when it shouldn't be. I just checked the layers, the draw layers function. Let's check it again. So let's do draw layers. And let me just see what we have here. So we're starting at, we're going through all the frames. That's fine. And for every frame, we are basically concatenating the layers by starting J at layers.size minus 1. Okay. Then we say J less than 0. Yep. As long as J is greater than 0, we do J minus minus. Okay. Should it be greater than or equal to 0? Let me think. No, because we're always drawing on layer 0. So it should be that. Now let me think. Layers.size is going to return 3 here. So we want 2. So layers.size minus 1 is correct there. Yep. Yep. I'm not seeing what's wrong with that. Besides, it draws quite well for when we have two when we have two layers. So we know that it can draw over. Okay, so let me think then. Maybe I have this backwards? Maybe what I need... Let's see what happens if we put these guys on layer 1. Go circle layer 1. How did I do that? So we draw on... Oh, I see. I totally did this backwards. Let's change this to 2. Hey, Lolo. What's up? I don't think there is such a thing as a sim wave, at least not on my channel. But hey, how have you been? I think it's been a while. Right now we're kind of working on something known as a gift wrapping algorithm. The idea is that we have a random distribution of points, and we find what's known as a convex hull, or the smallest possible geometry that fits all of the points. That's kind of what we're working on right now. It's interesting. We'll see what happens. So what I need to do here then is actually go the opposite direction. So we want to do, instead of layers.size minus 1, we're going to do j equals 0, equals 1, add in a semicolon there, and then j less than, and let's do, 1 second. No, it's the viral video simulation actually finished a while ago. I just did not update anything because I'm bad at this. So let's do draw layers. I usually don't update things until the video's made on that thing, but I kind of failed on that one. I have not yet made the video for that. So it's going to take some time for, well, no, I can probably take it down whenever. So let's do plus plus j. Let's pop over here. And we're going to say size tj equals 1. And this should do it. Right, quit. Now let's make that. Give it a second to do its thing. Now let's run Jarvis. Okay, give it a second to do its thing. As you saw last time, it does take a little bit of time, but that's okay. We can kind of let this run and see what happens. The last thing we need to do is I kind of want to look at it, and I want to see if we want to remove those white lines or not. I think we do. I think we really do want to remove those white lines. But I want to take a look at it once everything is almost complete at that point. So, the viral video simulation should be out early next year, I guess. I want to do the gift wrapping algorithm. Then I want to make a quick video update video on YouTube for, how do I put this? I want to do it just because I kind of had the feeling that Well, most of the people who watch my YouTube channel probably don't know about my Twitch stream. That's one thing. And I don't really have that many more people who watch my YouTube channel. You know, it's like 1,300 followers versus I think 800 followers on Twitch or something like this. I don't really keep track of my Twitch followers as well. Maybe I should. Oh no, I keep track of the ones who come in. I just told you what I was doing a second ago. We're doing a gift wrapping algorithm here. So here's kind of an image of what's happening. Yes, so this looks okay. So let's scroll down. Actually, can we zoom in? Let's zoom in. No, that doesn't help. All right, let's just go ahead and finish up this. Okay, so here's our gift wrapping algorithm here. Oh, just barely enough points. Yeah, that should be okay. Okay, so let me zoom in. Here's what we did. We traced out what's known as the convex hull of this system. The idea is that basically at every single point, we searched all the other points in the space, and we tried to find the one with the greatest angle, okay? So now let me think. What do I want to do for this angle? What I want to do is every time we draw a line, I want to... Do I want to draw out the angle? Let me think. Well, let's go ahead and change the way that we're doing this visualization. And let's see. I want to do it this way. 876 on Twitch? Wait, what's 876? A what trapping? We are doing... It's not a trapping. It's called gift wrapping. It says so in the title of my stream. It's the gift wrapping algorithm. Let me just go over here and let me just Google gift wrapping algorithm. I just realized we have like no one watching, but that's okay. I misspelled gift, a 2 apparently. This is what we're doing. It's relatively straightforward, I think. So, okay. Now we have that done. There's one more algorithm I want to get done today, and we'll see if we can get to it. Now, let's go ahead and clear the context. Let me see. I have create background. Let me see what that one does. And let's do create BG. Oh, create background here. There we go. And what do we do? Cairo set source RGB, Cairo rectangle, Cairo fill. Yeah, how about we do that? How about at the end here, instead of clearing the context, we create the background on layer 0. Yeah. So I can create the points for drawing a model or something. Kind of in a way. I mean, the idea here is that we're finding something known as the convex hull, right? And the convex hull is a geometrical thing, right? So the idea is that we're finding the minimal possible shape that can hold all of the points, right? So there are obvious applications in, for example, Happy Little Rats area of game physics, in my area of real physics. You know, it kind of depends. But now Twitch no longer shows the stream title. What do you mean it doesn't show the stream title? Let me see. Go here. It's right down here. Gift wrapping. My screen's a little bit weird here, but that's okay. Let me see. What do I have? Good. I don't. Oh, I do. Dang. Okay, that's okay. Doesn't matter. I also don't know if I turned on Nightbot. Did I? Maybe I did. I don't remember. 1 second. Log in. I guess he might not be active. That's okay. Doesn't matter. Okay. So what am I going to do next? Well, we can visualize the angle, but what I want to do next is the following. I want to say create background, and it's going to be on layer 0, and we're going to do RGB all equals 0. I think. Go over here, quit, and let's do a make on that. I think it has to be layers plural. Oh, it could be. Make. Now we're going to do Jarvis. Give it a second to do its thing. It's going to take a little bit longer than last time, but not that so long. Wait, it doesn't? Did it change recently? Huh. I too am on a desktop PC. So, oh wait. Our interfaces should look quite similar. Is this not how everyone else's looks? Let me see. Yeah, I'm not sure. If your interface looks different, I'm sorry. I don't know how to fix that one. So let me go to the last Mirage. Let's scroll down. Okay, so we draw all the lines. Oh, no, none of the lines are being drawn. Yeah, none of those lines are being drawn at all. Crap. Animate line layer 0. Create background layer 0. Oh, I see what's happening. Crap. Yeah, I've never used Better Twitch TV, so I don't know. So what I want to do then is I want to just go ahead and remove this. And I want to do... I now see a bit of a problem with what I was doing before. Okay, so let me go ahead and... Let me see, what do I want to do? I want to go into this file over here. And when I go to create background, I want to basically take this guy and I want to copy it again. So let's say, move it down here. And I'm going to call this color background. And we'll do frame in it. And then I also want to hear how I screwed up my Vim on my Office Mac? What did you do? So we're going to do int start layer, and this should do it. So now what we're going to say for int equals I equals 0, this is going to actually do start layer. There we go. And now instead of, let's see, what did I do before? Let me see, can I undo? Yes. So we're going to do color background. And we're just going to be layers of 0, but it's going to be starting on frame layers of 0 dot current frame. And let's go over here real quick and let's change this up just slightly. So it's going to be instead of start layer, let's start layer is okay. Write this. Let's go ahead and grab this and let's put it into rank width visualization.h. Let's go down to create background, create frame background, and let's just go ahead and put it down here again. Paste. Oh, sorry. Open. There we go. Create basic color background. Yeah, this should be okay. Good. Add in a semicolon, and that should be it. Let me see. What's this look like? Open link. Huh. I have never seen this interface before. Interesting. Oh, okay. Maybe this is... Huh. I don't know, man. I don't know. I pasted the shell script into the terminal. Let me do a make. And now we're going to run a ./Jarvis. Okay. What do we have here? Running all his Vundle commands. So pasted the shell script into the terminal, running all his Vundle commands. Okay. Open link one more time. Yeah. Yeah. This is totally different. Weird. I don't even know how to get that interface. Let me see. So you basically broke it by running all the commands you were supposed to run. Is that what I'm getting, Slayer Darth? I committed some changes today to my colleague's shell script. I accidentally clicked the mouse scroll button. Oh, I see. So you click the mouse scroll button and you copy and paste it. Yeah, I see. Okay, so let's do Mirage. Scroll down. Here are all the points. It's still broken. Why is it still broken? Let me think. Yeah, I don't know. Okay, so let's see. What do I want here? We want to start at layer 0 current frame. So let me pop down here real quick and let me see what we have. Color visualization at CPP. Let's do color background. Here it is there. And we say we start at I layer. And we do current frame. Frame context I. Okay, let me think. Cairo fill. Did I write this? Yep, I did write it. Okay, so we start at I equals 0, but here we start at start layer. But yours is showing no title. It's strange how yours... Wait, how yours show is strange. Oh, I see. I'm also getting a SS, so you can see what I get. Wait, what is an SS? Sorry about that. Okay, super sorry about that. That's what the SS stands for, super sorry. Okay, background. Frame animation. Start layer. Int R, int G, int B. Okay. So we say Cairo set source RGB. Oh, the idea here is that we have basically a number of points on the outside. Here, let me just go ahead and show you what we have so far. So we do, 1 second, Mirage, we take a look at the images. Basically, the gift is a random distribution of points. And then the idea is that we basically draw lines connecting all the top, or connecting what's known as a convex hull of the system. So here would be all of the outside points in here. Now, in principle, we've done this multiple times before. However, we're trying to get the visualization just right. So if we scroll in, basically the idea is that we're wrapping this, wrapping all the exterior points together. And that's kind of what we're doing here. Let me see, screenshot. Oh yeah, okay, good. So let's see if we can figure this guy out. So why then are we, basically what we're doing here is we're saying layer 0.current frame, 0, 0. So basically after we draw, we should be coloring the background on the current frame. But for some reason, it's not quite doing what we want it to do. So layers 0.current frame. We animate the line. Yep, that seems good to me. Layers 0.current frame. Layers of 1, layers 0.current frame plus plus. Yep, that all seems good. 4. Huh. Okay, so final angle equals angle temp. Yeah, this should be okay. Yeah. Yeah, it doesn't seem to quite be working right. So color background. Sorry about that. Of the first layer, that's going to be the background layer. Huh. Why is this not quite doing what I want it to do? Pop over here. Let's take a look at that function. So color background. So we start at the start layer, and we go to all of the frames. So we draw all the frames in black. That seems fine to me. So we say Cairo set source RGB. Okay. We say animation.frame context, double of RGB. Yep, okay. So we set the source to black in this case, for each of the frames. Good. Then we say Cairo rectangle, so we basically draw an entire rectangle, and then we color it in. Animation resolution X, animation resolution Y. Yeah, Cairo fill. It seems fine to me. Animation frame context I. So, what then is the issue? Oh, also, Eltmon, for the record, if you want more information, just take a look at this right here. That article will give you all the information you need. Okay, so what I want to do then, Cairo rectangle, Cairo fill, it seems like we're only filling above that particular frame context, but for some reason, it's not quite doing what I want it to do, so let me see. For j equals 0, I guess what I should do is just output something real quick, so let me do an stdc out. And I want to do layers of 0 dot current frame end line. 1 second, let's pop over here, right quick. And let's do, 1 second, I gotta think here. Make, and then we have to run Jarvis. Give it a second, and we have all these guys outputting. Now let's see what happens here. So we have 201, 301, 401, 501, 601, 70. Oh yeah, this is fair. This is fair. This is good. 8, 9, yeah, 12. Okay, sure, fair enough. Yep, I get it. Totally get it. Okay. Huh. Okay, so let me think. This is correct. We're fine with this. I'm fine with this anyway. Maybe you guys are not, but I'm okay with this. So that means that the frame that we should be drawing to starts at 101, 201, 301, 401, 501, so on and so forth. However, for some reason we're not doing this right. So let me think of something else then. How about, do we actually care? No. Here's what I want to do. Let me see. Let me go into the animate line function. Let me go in here. 1 second. Cairo visualization. And I got to do, instead of animate line, I just want to draw a simple line. So let me go into Cairo visualization.cpp. Let's go to animate line. I know how to solve this issue. I totally know how to solve this issue. Let's, instead of going to animate line, which is what I'm currently doing, let's go ahead and just remove a couple different guys here. So instead of color background, I'm doing this way too complicated, guys. So remove this, animate line there, and let me see, Cairo line 2, that's what I want. I want origin.x, origin.y. So what I need to do is very quick, up here, before this for loop, we're going to do Cairo move to. So it's going to be, 1 second. Where's it? Cairo move to. And we're going to move to animation dot frame context. 1 second, context. Of, what do I want here? I suppose I want, 1 second, it's not animation, it's going to be layer of 0, dot frame context. Layers with an S, I always forget the S. Layers frame context of, I guess layers of 0 dot current frame. Okay. And then I want to move this to, 1 second, I gotta think here, to origin 1.x, origin 1.y. So let's pop this down to the next line. And we're going to say, not current hull, but, oh, I guess it's going to be a.x and a.y. That's what I want. Okay, let me go ahead and remove this extra line that I accidentally created because I pressed the wrong button. And there we go. Okay, so we moved it there. Instead of animate line here, I'm going to go ahead and delete this guy. Oh, no, not yet. I'm going to do Cairo line 2. Actually, let me just grab these two guys. Yank to yank. Paste them down here. Okay, and let's go ahead and remove, instead of A, lazy Cairo line 2, let's do b.x and our b.y. Okay, and this I think should do what I want. So let's go ahead and remove this line, and that line. Write this, go over here, quit, and let's do make, and let's do Jarvis. It should also be much, much faster, I think. Segmentation fault. Well, that's good. We're getting there, guys. We're getting there. Okay. So where's that seg fault coming from? Yeah, I don't know. It's interesting because it seems that there is a whole JavaScript animation that exists in Edge and just isn't executed in Chrome. Huh. Yoga is a great idea. I don't know what yoga is. Oh, I know what that yoga is. I thought yoga was a I'm sorry. For some reason, I thought you guys were talking about internet browsers, and then I heard yoga, and I thought yoga was an internet browser. My bad. I misunderstood. Okay, we have a segmentation fault. What does that mean? Well, it means that we're drawing to a frame that doesn't exist. Well, that's good. So what do we need to do? We do Cairo move to layers of 0 frame context, layers of 0 current frame. Okay, so let's increase the frame number then. So let's do Cairo visualization.h, if I can say anything right. Let's increase this to 2000 just to kind of, you know, see if this fixes anything. So now we're going to run make, and then we're going to Jarvis. If I can spell Jarvis. There we go. Okay, give it a second to do its thing. And should be drawing right now. This should be way less than 2000, so we should be good. Give it a second to do all the drawing. And then we're going to do... 1 second. Okay, so now we're going to run the last Mirage. And let's see what happens. So if we scroll down, we have all these points being generated. Oh no, it's not drawing the lines. Crap. And we still draw the convex hull. Dang it. Okay, we gotta do this one more time. Okay, so why are we not drawing the line? Cairo move to, oh, I forget to Cairo paint. So Cairo move to, or what is it? Cairo stroke, I think? Yeah, Cairo stroke is what I want. Cairo move to, in here. And then where's Cairo line to? Oh, shoot, I just moved it. There we go, Cairo line to, and then I want to do a Cairo paint. Paint? No, not paint. Stroke. There we go. Gotta stroke your stuff. Then we're gonna do layers of 0 frame context. This is quite long, but it should still be okay. Let's go here to make. I'm missing a lot of chat. Sorry about that, guys. Let's run Jarvis. Okay. Let me see. Oh, this one should be fine. Let me see. At the beginning, everything always hurts. Don't push yourself too hard. If it hurts really, maybe you need to see a doctor. Oh. If you'd rather pull out your back and much more intense pain, roll on your ankle, sprain, a stretch will be better with time. Yeah. So I work out every day after stream, actually. And let me see what happens. No, it's still not doing it. Dagnabbit. Why is it not doing it? Is it because I'm not setting the color? Maybe that's it. Maybe I need to reset the color. So let me go over here and let's do animate line one more time. Or let me look at animate line. I need .cpp. Let's go to animate line. What do I do at the start here? I should set the color somehow. Color. Yeah, that's fine. Color. Okay, Kairos set source RGBA. That's what I need. Okay, so let's see Kairos stroke. And what I want to do is just before the Kairos stroke, I want to do Kairos set source. RGBA. And I want to do basically this guy here. And then I want to pop down here and I want to say, what do I have here? Do I have color? I have line color. Dot R line color dot G line color dot B, and then line color dot A. Oh my gosh, it doesn't quite fit. Ah, dagnabbit. I misspelled line on that last one too. So we're gonna put that down to the next line. X here and AE. Pop over here, quit, and let's make this, see if it works. Line color is not defined. That's because it's that. Make. Maybe that would have fit in the last line. Now let's try it one more time. Okay, let's see what happens. What am I missing here? Loyal, yoga mat, not really. Towels. Oh, towels are gonna be awful. Stuff like crunches instead of having your back on the ground. Yeah, honestly, so I broke my tailbone when I was younger, and I can't do crunches on the ground very well anymore. So let me go to Mirage. Like, it kills my back. No, we're still not drawing the lines. Where are those lines? Let me see. We should be drawing a line. Cairo line 2. Frame context. Layers 0. We should totally be drawing a line. I think. Cairo set source RGBA. We're setting it to be white. Yep. Line color. Do we do a Cairo stroke? What am I missing here, guys? Let me go to CPP, animate line. Animate line, what do we have here? Cairo line 2. Those individual characters. Cairo set source, RGBA. Cairo stroke. It looks like we're set. I don't see what the problem is. So we do origin.x plus double J, origin.x minus, yep, this is all okay. Wait, current x is equal to double J. Oh, I see what we're doing there. Okay, that's fair enough. Because we're animating the line. So we need to kind of like interpolate a little bit. Okay, Cairo line 2. Animation.frame context I. Origin 2 x. Origin 2 line. Yep. Okay. So what is the issue? RGBA, color.R, color.G, color.B, color.A. Animation frame context of I. What are we doing here? Animation layers of 0.current frame. Maybe we should just output the current frame every time? Just to make sure we're actually doing something. So I'm just going to do that. So let's do... No, but we totally should be, right? This should be an integer. Cairo stroke. Animation frame context. Layers of 0.current frame. Okay, let me see. What is the issue here? Layers of 0 dot frame context of layers of 0 current frame. So we're going to the current frame. We're increasing the current frame every time step. We're drawing a line from A to B, should be. We set it at A. Huh. Is it because I'm not moving to... Oh, I bet you that's it. Let's put this inside this loop up here. Yeah, I bet you that's it. So let's pop up here, and let's go ahead and do a yank to yank. Bring it down here, and let's see. I want to do this. Paste it. Ooh, what happened there? Yank to yank. And let's paste it here. There and there. What? Okay, I'm not exactly sure what's happening there. That's okay. So Cairo move 2 up there. And now let's see what happens if we do quit. And we do make. And then I think they should draw it. Let's see what happens. Give it a second to do its thing. Takes significantly less time to draw each of those guys, which is good. That's good. Okay. 1 second. Still drawing all the frames. Okay, now let's do the last Mirage. Scroll down. Okay, so we are drawing all these lines now, which is good. Okay. So here's what the simulation looks like now. Okay, so we draw all these lines. Yeah, okay, this is manageable, I think. Okay. Okay, so what do you guys think about this animation here? So this is kind of exactly what we're doing, right? So we start with the first one, and we search through all of the points until we find the one we want. And then we kind of move from there, right? So we keep going, and we keep searching through all the points until we find exactly the one we want. And then we kind of, you know, procedurally keep going until we find the entire whole. So that's the gift wrapping algorithm right there. This animation, I think, is pretty close to being done. I kind of like it. I think it's okay. There's some stuff that we could do to it to make it a little bit better, but that's okay. So let me go up here and let's change this line color so that it isn't halfway invisible. Let's actually make it fully visible. Let's make it a 1. Let's go down here and let's do... yeah, so let's do make one more time. And then we're going to run Jarvis. Okay, so this is what's known as a Jarvis March, or the actual gift wrapping algorithm. However, there are other convex hull algorithms out there. And one that I kind of wanted to look at, although maybe not code up today because we don't have as much time as I would like, is the Gram Search, I think is what it's called. Gram something. And I'll take a look at this maybe directly after work today, and we'll see what happens there. So Mirage here. Here is our convex hull. There's all of our points being generated. And we go through and we kind of just search. Yeah, this is okay. Yeah, this is pretty good. I'm okay with this. We can always slow it down if we need to. Okay, that's pretty good. I'm okay with this being our convex hull search, or present wrapping, or gift wrapping algorithm. This is fine. Yeah, I'm okay with this. Okay, that seems good to me. So 1200 seconds at 60 frames per second means that we are going to be at what? 20 seconds? 1200 frames at 60 frames per second is going to be 2 seconds. No, 20 seconds. That's how long it's going to be. I wonder if a 2-pass algorithm would be faster. First pass is limited to the closest neighbors, and second pass is your algorithm. First of all, this is not my algorithm. My algorithm is, I did not make this one up. This is the gift wrapping algorithm over here. So I'm just pulling from someone else's algorithm here. Now, this is inherently slow. There are ways to speed it up. In fact, we're going to do right now, a faster algorithm. But what I need to do is I need to create a new file for this new one. So basically, this new algorithm will be faster than this one with larger numbers of points. So it will be faster. However, it will not be faster for lower number of points. So in the end, what we're going to do is we're going to introduce a faster algorithm for a large number of points, and then we're going to introduce an algorithm that uses both the faster and the slower one together to make it as optimal as possible. And in this case, it is kind of a 2-pass algorithm like what you're saying before. And that's going to be the fastest possible. It's called Chan's algorithm. And it's something that I want to look at either later today or tomorrow, and we'll see what happens. In fact, guys, why is everything booked? I have like no time this weekend. So maybe I'll be making this gift wrapping video over this upcoming week. I definitely want it out before next weekend. Let me see. So what day is today? Let me open up a calendar. It is the 16th of December. So I guess I'll be streaming over the weekend, 17th and 18th. And then hopefully the video will be out like next Wednesday or something. I'd like it to be out on the 20th or something like that, ideally. I mean, ideally I'd have it out actually tomorrow or something like that, but I don't know if I can do that or not. So we'll see how far we get. There's a lot of stuff left to do, a lot of studying that I need to get done before that. But for now, we do have this one working, so let me go ahead and comment stuff in, just so this isn't like a complete mess of what's happening. So first we need to draw the random distribution of points. This seems fair enough. So we create the vector origin, we create the x and y range. Let me just say, arbitrarily, cutting 10% of the, let's say, X range of the resolution. 4. So circles can fit. Okay, so actually, let me clarify. When I say study, there's a whole bunch of things I need to look up. Before each of these algorithms, like before I do anything on this stream, I spend a lot of time looking up things online. Like, a lot of time. So like, for example, last night, I spent the entire time reading a paper on, one second, the ultimate planar convex hull algorithm. That is actually the name of the algorithm. And it's quite cool. And then let me see, I also have a number of different algorithms that I've been looking up. Ultimately, I was going to use the ultimate planar convex hull algorithm for this particular video, but it's complicated enough that I think it fits in its own video, and Chan's algorithm is easy enough to implement that I think we can probably get that done for this video that I want upcoming. So the kind of studying that I need to get done is mainly just for my own benefit and understanding things for this stream. However, in terms of actual work, I currently am working on GPU computing methods for something known as a Bose-Einstein condensate. The idea here is that the Bose-Einstein condensate is a superfluid, and we basically do vortex manipulation and stuff. It's quite cool. I mean, obviously, I'm more interested in the numerics than the physics. Don't tell my boss. Actually, my boss watches these streams sometimes, so he might actually already have heard that. Oh well. But he knows that. I mean, he knows that I signed up for the project because it was a sufficiently complicated numerical problem to solve, and not necessarily because the physics was exactly what I wanted to do. And so we kind of butt heads every now and again, but it's fine. I think it's fine. I mean, I couldn't ask for my boss to be any cooler than he is. So, anyway, so that's it. So basically working on Bose-Einstein condensate and superfluid stuff. I don't want to go too much into it because I don't know how much I'm actually allowed to get into, but basically, yeah. Vortex manipulation in superfluids. That's what I do. Okay, so let's pop down here. Well, isn't it based on what he's planned for stream and always changing? Now that I'm questioning the validity of the question, just noting that it's a question that answer would constantly change based on the day of the stream. Yeah, that's true. So what I'm studying on the side is always going to be kind of sort of based on what I'm doing for stream. So, you know, I don't really have time to do much else other than study in my free time, you know, so I spend basically all day studying for work, and then all night studying for stream, and then all morning doing stream. It's just, I don't know, I don't have time for like anything. I'm literally booked from 5 o'clock in the morning until 10 o'clock at night, like every single day. That's kind of my entire schedule, you know, which is why sometimes I get up a little bit late, because sometimes if I get to bed late, like at 11 o'clock, which was last night, I just can't get up in the morning. So there's sometimes situations where I clearly am overworked and I'm just not getting enough done in any field. Sorry about that. Needed a quick sip of water. Okay, let's go ahead and continue commenting this guy. Put it on GitHub, and then we'll work on the next bit here. Okay. So what do I want to do? I want to go in here and I want to say layer 0.9, what are we doing? Origin X. And here I want to say grow circle command from visualization. If I can spell visualization, Cairo. One second, Cairo visualization dot star. Do you sleep about 6 hours every night on average? Yeah, about 6 hours. I mean, I get enough sleep, you know? It's not like I'm stretched for it. But yeah, 6 hours is about right. All this different research that, for me, go into one big project, we could really vastly different things. Yeah, that's true. But actually, truth be told, I've always gotten around 6 hours of sleep, you know? So like when I was in high school, hey Nasimiko, what's up? Konnichiwa, which is actually Ohayo gozaimasu for me, but that's okay. What am I going to say? I'm going to say, yes. So when I was younger in high school, I had to get up at 4:15 in the morning for swim practice every morning because I was a swimmer. And so I'd always go to bed at, well, in order to get a full 8 hours of sleep, I would have to go to bed at 8 o'clock at night. No way I was going to bed at 8 o'clock at night. You know, 8:30 was when we actually were supposed to go to bed, but I always had homework to do or something like that. So I'd always go to bed at like, 10 or something like this. So even so, I would only really get, I don't know, Gastorn. Oh, Yasumina Sai? Oh, that's bedtime. But yeah, so I'm very used to getting very little sleep, and so it's not that big of a deal. I'm totally used to it. That's why I like this stream. He actually does what I should be doing, not some content. But I do kind of look up to Simuleos because he is so consistent. Oh, thanks, Edge. I do try to get up every morning. Every once in a while, like this morning, I start late, but you know, I try to be here as often as possible. So I think this is all self-explanatory. Layers 0 current frame, resetting the frames. I'll just go ahead and add in a comment there. Okay, so what do we have here? Defining all the variables. This is no longer necessary, so we go ahead and get rid of that. And now this one, we're going to say, basically drawing until we return to our original point. Okay, so let's pop down here, a.x, a.y. So we're going to say A, and let's go up here and let's define what A, B, and C are. So we're going to say A is, what's A going to be? 1 second. Oh, okay, so A is going to be the current whole point. B is going to be, 1 second, B is, how do I put this? Checkpoint. And C is new whole line. This should be hopefully explanatory in a way. Open link. Oh, okay. So what do we do here? A.x. This should be okay. Int first frame. Do we even use first frame? Let me do a quick make. Do I have clean? Make clean. Make clean. There we go. Make. Yeah, I don't use first frame here. So let's go ahead and remove first frame. And let's see, can I remove 2? Yes, so we don't need this can I remove 2 anymore. Okay, so now up here we get a little bit complicated. Do you at least use a couple of hours on your day to just relax and avoid burning out? No, the couple of hours I spend relaxing is actually when I get home and I start reading papers for the stream. I don't think you guys realize that I'm like a huge introvert. Like at work, I don't go to lunch, not because I don't like going to lunch and I feel like I need to work over lunch because I feel like I'm not working fast enough, but because in the end, I can get more work done during lunch. If I don't go to lunch, that's one thing. And I actually just really don't like socially interacting with people. Like, it's to the point that, like, there are all these parties that I could go to. And to be fair, when it's not 5 o'clock in the morning, I'm very good at communicating with people. I'm very good at approaching people, talking to people, getting things done in a work environment. But in a social environment, I just cannot, I don't understand it. Like, why would I go out and interact with people? It's like, why? It just doesn't make sense to me. And so, like, I just don't go out and things like that. So for me, sitting home and reading a paper is like the perfect night. You know, like, it is exactly what I want to do. Sit home, read a paper, maybe work on some algorithms or something like that. Every once in a while, I'll put a YouTube video on the side. It's nice, you know? It's pretty much exactly how I'd want to spend a night, no matter where I was. So it is relaxing for me, in a way. And so I think that's kind of my answer to your thing. In some sense, yeah, I know it's not normal, but yeah, actually, I don't have time to watch other people stream. In fact, all the time I watch YouTube videos, there's this interesting thing you can do with YouTube videos. I guess I'll just go to youtube.com here. Why not? I'll go to my channel and pick out a video. So let's just go to my channel. Pick out a video. Yeah, why not? 4D video. You can actually set all these videos to be on 2x speed. And I do that all the time. I always do that. Every one of the YouTube videos I watch is at 2x speed. It's gotten to the point that sometimes I will actually watch someone, like a 30-minute video is now only 15 minutes for me. And when I watch people at 2x speed, I'm so used to them speaking incredibly quickly that when I start watching them at normal speed, it's like, man, why are they speaking so slow? And I have to just stop watching the video. Extra Credits is this way. I watch some of their videos. It's weird. Anyway, yeah, that's kind of my thing. I enjoy learning things, I guess. And so that's why being a graduate student is actually a very good position for me to be in now, because like my entire job is learning things and I really like it. You know, I love just sitting back, trying to figure things out, piecing up puzzles. It's nice. Okay. I'm gonna have to be right back again. My nose is all stuffy. Give me just a second. Sorry about that, guys. Normal. I've been thinking about what streaming my research time, as long as I don't think it's going to cause insecurity in my stream. Yeah. This Windows Manager is OpenBox. Let me just type that in so you can hear it. OpenBox. OpenBox. Okay, so let me go ahead and finish commenting this in. So what do we have? Angle temp. And let me say the angle. Should we visualize the angle? Maybe we should. Yeah, let's visualize the angle. It's not so bad. The color set source RGBA. Maybe it's okay. Let me think. What do they have here? Yeah, they have it just defined there. Let's take a look at the last Mirage. Scroll down. There are all of our points being generated. Yeah, I'm okay with this. Yeah, I'm okay with this. Yeah. That's the reason I study physics. I love learning new things all the time, and I feel like day-to-day life would be boring doing the same thing over and over again without learning anything new. I tried this fall to take a load of courses, and while I did, I have something to do all the time. I basically had to study for 10 hours a day. It did feel very exhausting after a couple of weeks of just not getting a moment to relax in between studying. Yeah, so as an undergraduate, man, there was this one class. It was electrodynamics, E&M, electricity and magnetism. That course beat the living daylights out of me. Holy crap, that course was hard. Like, up to that point, I never really had to work for any of my classes, you know? Like, I was valedictorian of high school, you know, so I was the smartest kid. It's not true, but, you know, that's what everyone kind of said I was. I go to college. I want to be an author, and I just write every day. Like, every day I spend all my time writing fiction and fantasy. It's fun. I enjoy doing it. Still, I enjoy writing, actually. And, then I just took my freshman physics course, and I was like, oh, this is interesting. And I just kind of decided that if I wanted to be an author, it didn't really matter what major I was. So I switched to physics because I was like, hey, screw it, I'm gonna do physics. And then when I took my first actual physics course, which was electrodynamics, E&M, man, that course just killed me. Like, I remember being up all night, working through every single problem in Griffith's electrodynamics, failing miserably so hard at everything. I was bad, you know? And the truth is, it takes time, you know, for me to get better and better and better. And I don't know, it took a while. Now I finally feel like I'm catching up to all of my peers, but I'm still behind, you know? All of my peers are way smarter than I am. And I just need to get better, you know? And that's the thing. That's kind of why I'm doing the stream to begin with, because it allows me to learn things that I know I would never learn outside of this, you know? Nisimiko, how old am I? I am actually only 24, which is weird because I look at my statistics and most of the people watching my channel are older than I am. So on YouTube, they're like 25 or something like that. Another reason I like hanging out here is because Simuleus is likely to pull in Linux users. I see him as a potential user of my software in the future. Oh, it's of course based upon his choice of wanting to use my system, but I totally think they would love it once he hits that point. What is that point? Anyway, let me finish commenting this in so I can put it on GitHub. Okay, so what are we gonna do? Drawing a single line. Wait 1 second. So we go here and let's say, here, drawing a single line. A single line for each frame. And I want to put a quick note here. Note animate line draws over all potential frames. Okay, good. So we'll do set source, RGBA, Kairos stroke, and then we increase the line number. Yeah, I know, right? Maybe I have bags under my eyes, like permanent bags under my eyes, and worry lines on my forehead. So a lot of people think that I'm way older than I actually am. But yeah, I'm 24. I'm maybe 25? One second, let me think. No, 24. Yeah, I think. Crap. I don't celebrate my birthday, so sometimes I forget, but fairly certain I'm 24. Yeah. I'll have to look that one up. Okay, so increase frame number. And I think that's all we really need to increase here. I'm sorry. Like, the truth is, I don't have to put my age on anything. Everyone asks for my birth date. And so I put my birth date down, and then it's like, how do I do the subtraction here? And then I'm like, wait, but I was born this point in the year. I don't know, I'm sorry. Forgive me for that one. Now what I want to say, drawing the next hole. Yes, that's what I want to do. Okay, and finally we're going to do drawing the wrap paper or next hole. Okay, so this should be good. See out eye, well, yeah, we can leave it from there. Good, so let me go ahead and write this. Let me make it one more time, and let's run it one more time just to make sure it does what we want. So ./Jarvis. Oh, is the makefile committed? I don't think the makefile is committed. So let me do a quick git status dot. If I can spell status. Yeah, the makefile is not committed. So let's go into the makefile. And let's modify a couple things here, guys. So what I want to do is I want to move jarvis.cpp into gift.cpp. How about gift wrap? And this will make a little bit more sense in just a second. Gift wrap VI. You're right though, 959. I don't think you realize. Let's see. Gift wrap. There we go. Remove a couple lines over here. And now what I want to do is remove the Jarvis back here. Okay, so now we'll have Jarvis, which is good. Don't get me wrong, Jarvis is good, but we will also create a new function in just a second. And I guess because it is kind of late, I will go ahead and describe what the new function is, and then we'll kind of go from there. So instead of jarvis.h, yeah, let's change this to giftwrap.h too. So gift wrap, okay, right quit, and let's move jarvis.h into gift wrap.h. Almost pressed enter there. That would have been awful. Okay, so now what do I want to do? We have the gift wraps. And what I want to do next is I want to go into gift wrap. Gift wrap.h. And I want to change this to gift wrap.h. Just because, screw it. And change these guys to gift wrap.h. Okay, let's do gift wrap. Pop this down here. There. Okay, so now let's pop over here, change all the Jarvises to gift wrap, and I think I can just do it this way, unless I am wrong here. So Jarvis to gift wrap G. Write this, and let's go ahead and comment that out. So now let's do make, give it a second to do its thing, and we'll let it run. Seems to be okay. And then we'll take a look at the images, and we should be good to go. From there, I'll go ahead and commit it to GitHub, and we'll talk about what we're going to do next. So what's your favorite course, subject that blew your mind? For me, holy cow. So, I did this thing in college that maybe I shouldn't have done, but I totally did it. So when I was in college, I had the choice to take either courses I wanted to take, or take the courses that were required of me by my curriculum. And in the end, I decided, screw it, I'm going to take the courses that I want to take. There we go, gift wrapped. And so I ended up first starting with physics. And I said to myself, okay, well, starting from start. Started with English major, actually. I wanted to be an English major. Then I said, screw it, doesn't matter what major I want to be, so let's do pre-medical something. And so then I decided, okay, well, I'll do pre-medical physics, right? Because I thought, okay, well, being a doctor is nice, being a physicist is nice, putting them together has to be okay. So then I started really focusing on the physics, and I realized, oh man, I really, really like the physics, you know? And so I went through, and the first course that blew my mind was E&M. Holy crap, the amount of math that was involved in that course was ridiculous. Then the second course that I love to this day was thermodynamics. Holy cow, it was like everything was just statistics. I was like, how do you go from probability theory to statistics? I was like, holy cow, that's so cool. Then modern physics also blew my mind, because I'm sitting here and I'm thinking, relativity? What does this even mean? How does the speed of light move at the same speed regardless of reference frame? How is it always c? It blew my mind, completely blew my mind. The only course that didn't blow my mind was quantum. And the reason it didn't blow my mind was because my teacher didn't really describe very well why it was cool. Okay? So the three courses that really stuck to me when I was younger was electrodynamics, thermodynamics, and modern physics. Those three were very big for physics. Now let me point out that I'm now in a quantum physics lab. So nowadays, quantum physics is also something that blows my mind, which is why I'm currently studying it. But I don't know, everything's just crazy. I don't know why, but I just get so interested in this kind of stuff. But you know what? The real courses that got me interested in things, that really re-motivated me to do research, were actually mathematical courses. The courses of information theory and data compression. These two courses, and also coding theory, really just somehow, I don't know what they were or why they did, but they just really made me interested in studying this kind of thing and looking at it from a more mathematical perspective instead of physical perspective. And so, like, I don't know, everything just is crazy, because in college I decided I would only take courses that I would be interested in taking. You know, I didn't take courses because they were necessary. I didn't take easy courses. I took the courses that I knew would teach me something, because that was the point of being in college to begin with, to learn something. So my GPA wasn't great at the end. It was like a 3.6, 3.8, something like this. But it didn't matter, because I got into my dream institution anyway, which was OIST. So, I don't know, I've just been super lucky, I think. And I'm very glad to be here, because it allows me to study what I need to study when I need to study it, and it's great. Electrodynamics and special relativity were pretty fun for me. Next year, going for some quantum mechanics and differential geometry for general relativity. Man, I wish I would have learned general relativity. I decided against it because at the time I was kind of... I took information theory instead, and I'm very happy with it. You enjoy my theoretical computer science course for sure? Yeah, man, holy cow, I really wish I would have taken some computer science when I was in college. But the issue was, in order to do the computer science courses, I needed to go through the full curriculum. And the full curriculum involves doing the introduction classes again. And so by the time I realized I could do a computer science minor, it was already too late, because I would have had to do the intro courses, which were in Java, and I didn't want to learn Java, and I already knew C++ and Fortran and Python at that point. And I was like, you know what? Screw it. Because at this point, if I go through the curriculum, I'm going to have to redo these courses, and I don't want to do those courses. They're not going to be fun. And the real exciting stuff doesn't come until later. And even then, I don't really feel like... I don't know. I felt like at the time that I could have learned it on my own, and I think I've done a pretty good job of learning from people and doing things pretty well. Okay, wait. Let me just go ahead and commit this to GitHub, because I'm git status dot. So let me do a quick git add jarvis.cpp. I meant add, not af. There we go. Now we're going to do git add, and I want to add the makefile, and I also want to add giftwrap.cpp and giftwrap dot, and what do I want here? H. Now we do a git status dot. Okay, and this should be okay. So now let's do a git commit, and let's do a -m and say changing structure of jarvis.cpp. Finishing. What do I want here? Gift wrapping algorithm visualization. Okay. So let's do a git push origin master. And you guys should have access to the code right about now-ish. Somewhere around now. Okay, good. So that is now up. Now let's talk about what we need to do. There was mention earlier. I don't remember who mentioned it. I terribly apologize for that. But there was mention earlier about making this algorithm faster. This algorithm is incredibly slow. If we go through the visualization, let's use Mirage Temp, scroll down. First, we generate all the points. We can't generate them any faster. But then we go through every single one of these points. And we search to find which one has the greatest angle, basically. And then we create a new line, right? Okay? And then we do it again. And we do it again. And again, and again, and again, and again, and again. We keep doing it again and again. And this is terribly slow. It's n squared slow, right? It has to be. This is as slow as we could possibly be. We could potentially speed it up in a number of ways, but the algorithm doesn't call to speed it up. So now we have a question. How do we speed it up? Well, there are a number of different convex hull algorithms. And I think what I'm going to do is I'm going to introduce a topic. Then after introducing the topic, we're going to work on it tomorrow. Hopefully getting that entire thing done tomorrow. So we'll have a lot to do tomorrow. And then after that, we have to do Chan's algorithm after that. So this is going to be the idea. Let me go ahead and go to gift wrapping algorithm is here. But let me just search for convex hull. Yeah, this will do it. If you go to convex hull on Wikipedia, let's scroll down here. And let's go to, I want algorithm. Let me see, convex hull algorithms, Wikipedia. Okay, there should be a list of the algorithms. Okay, so here's the two that I want, Gram-Scan and Chan's algorithm. Okay, so Gram-Scan algorithm is the next one we're going to do. Now, Gram-Scan is faster than the algorithm we're currently using. Hey, happy little rat. But it is not faster for small numbers of points. It's only faster for large numbers of points. Now, Chan's algorithm is a mixture between both the gift wrapping algorithm that we just did and the Gram-Scan algorithm together. If you put them together, you get Chan's algorithm, which is as fast as theoretically possible. O(n) log h, where h is the size of the hull. So this is as fast as possible. Well, as fast as we can currently know. Now, there is one more, and I've told you guys about this one. I love this one. It's awesome. It is called the ultimate planar convex hull algorithm. Every time I read it, I just find it hilarious that, like, the paper itself. Let me see. Where can I find the paper? Let me just Google. Oops, sorry about that. No, I don't want to sign in. The ultimate planar convex hull algorithm, which obviously I've Googled before. And let me just give you guys the paper because it's great. Like, okay, the paper here, the ultimate planar convex hull algorithm ? That is the name of the paper. And they're like, this is the ultimate planar convex hull algorithm. And they're not wrong. They're not wrong because this is still as theoretically fast as you can get. It's still O(n) log h. However, Chan's algorithm is used more in practice. Chan's algorithm is definitely used more in practice because it's easier to use. Everyone knows the Jarvis March, which is what we just did, and the Gram-Scan is also very used for convex hull things. So put it together and you have Chan's algorithm, and it's used more frequently. So what we need to do next tomorrow is going to be introducing the Gram-Scan. Now, here's the thing. I don't fully understand how the Gram-Scan works. I was hoping to learn that on stream. However, because it's 6:47 in the morning and it's pretty close to the time that I end my stream, I think I want to leave this as a bit of a cliffhanger, and figure it out tonight. Tonight when I'm not streaming. And that should do it. So I'll figure this one out tonight. Then after figuring it out tonight, I will code it up tomorrow, hopefully getting the visualization, everything done tomorrow. For this particular one, and then getting Chan's algorithm completely done the next day. And hopefully I will have all the audio of the video done Saturday night so that Sunday evening I can get the video out, which will be your Saturday evening. Oh, Saturday morning. Yeah, something like this. I'll try to get the video out as soon as possible. Yes. Okay. So that's my YouTube plan. I'll get that out, and then after that's out, one thing I also want to do is, what is it? Oh, for New Year's. I'm sorry, Zython. I always stream from 5 to 7 in the morning. Today I kind of started late, and because I started late, it kind of pushed the whole schedule forward. So I'm probably going to end quite soon. But hey, guys, I do want to ask you guys a quick question. So my channel on YouTube right now is focused mainly on delivering educational content. However, the educational content is very, how do I put this? It's hard to understand for anyone just tuning in. I always have a mathematical equation on there of some sort. Now, of all the videos I've made, my favorite video I've made is actually, no, I like all my videos actually. All my videos on YouTube I like. That's one thing I right now, all the videos on YouTube I like. There's actually a large number of videos you guys don't see that I don't like, that I took off because I didn't like them. But now all the videos that are on, I do enjoy. But I'm wondering, I'm going to try to do a vlog style video type of thing, one for New Year's Day, basically. I want it to be resolutions for 2017, what I intend to do for the channel and stuff like that. And I'm wondering if you guys would mind if I spend a little bit more time doing animations. What I want to do is I want to take this library that we're making here, and I want to actually turn it into a real visualization library for two-dimensional C++ stuff, because I've used it a lot. I continually use this library for a whole bunch of different things. And for me, as someone who does a lot of physics and stuff here, are you rendering the gift wrapping in 3D? Unfortunately not. I'm not doing it in 3D. I thought about doing it in 3D. I wonder, can we do this in 3D? Gift wrapping. 3D. I think, let me see. Maybe we could do it in 3D. Maybe instead of moving on to the other algorithms, I do the gift wrapping algorithm in 3 dimensions. What do you guys think? Should we do this in 3D? Or should we move on to the other algorithms? Complexity of convex hull in 3D, sure, fair enough. Gift wrapping. If not, protest. So what would it be in 3D? Yeah, you're right, it's n cubed. That's totally fair. So here's the gift wrapping in 3D. So let me see, what do we have here? Let me zoom in a little bit. We have the list of points. We generate a triangle. Okay, that seems fair enough. Generate a second triangle. Okay, so what we're doing is generating a whole bunch of triangles here. That's going to be hard to visualize. That's going to be hard to visualize. Yeah, I think 2D is fine here. Adding 3D I don't think really adds too much to this particular visualization. Because I think it's just an extension to 3D. I don't think it's that complicated. Yeah. I think it's okay. I mean, let me point this out. It is complicated. It's way more complicated. We're adding a third dimension, and this takes a lot of time. It's really hard. Oh, it is, actually, Moopaloo. You're totally right. That's exactly what the gift wrapping is used for. It's quite interesting. I'm very happy with doing this. In fact, we are going to be using the convex hull definitely for some visualizations in the future. I know we are, because I have some ideas of how I want to use it. And I'm quite looking forward to how these visualizations will turn out. I'm actually really looking forward to them. I want to do an underlying fluid dynamic system and run a convex hull algorithm on it. I've got some very interesting ideas I want to try. I'm really looking forward to it. Anyway, I think, guys, even though it's a little bit early and I started a little bit late, I'm going to go ahead and end the stream here because at this point we can't really get started on anything new, and there isn't really much left to do here. Yeah, I agree, Lolil. So in my case, the library would only be used if it's commented well and I understood it. I don't want this to sound wrong, but else I could just copy paste code from so. Oh, yeah. Let me point this out. The library that I would be making, the visualization library, is basically only for my purposes, but I want to kind of make it a little bit easier to use and stuff like this, you know? That's what I mean. Like, I want to remake the library to make it, you know, usable and friendly for a whole bunch of people, basically. Yeah, I agree, Lolo. I mean, in the end, right, the point of this is for learning purposes. It's not for implementation purposes, right? So, yeah, sure. Once you get the idea of the algorithm, you can extend it to 3D. But you're right. In the end, I have had a lot of criticism on my channel because a lot of people argue that there is no reason to bring it to 3D when you could have just done 2D instead. So that's fair enough. I feature bloat problems? Oh, anyway, guys, I do think I'm going to end the stream here. What I want to point out is if you guys are not aware, we do have a Discord channel. Discord. Feel free to pop in there where you have access to basically chat and everything like that. Here, where's Discord? Here's Discord. We have a specific channel there for us. I'm there pretty much all day, just kind of chilling. Note that my day is not your day, so I will be up when you're probably sleeping, but that's okay. Anyway, guys, that's about it for the day. Thank you guys so much for coming in. Have a fantastic day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, when we work on the gram scan algorithm, then moving on to the Chance algorithm, and hopefully finishing up gift wrapping by the end of the weekend and getting a video out on that. It's going to be awesome. I hope. We'll see how it happens. I don't know. But I'm hoping it works. I'm hoping it works. Anyway, guys, thanks again for coming in, and I'll see you next time. Again, 5 o'clock a.m. my time, which is 2 hours before now your time. See you guys later. Have a great day. Bye, guys. That was a really messy outro.